And let's think about how we can search through this linked list. So let's just find D and C from this list, from the list. Okay, and just and actually this is first. And just write the list by an array. You can navigate from the first to the rest. Okay, there is no difference in search pattern. Actually, you can, but the thing is that though you cannot use the index any further, right? So if you know somehow where this head is, you have access to this head, right? Then you can call the head dot next node dot get value, and this will return A, right? And then the current node, we are going to implement a new thing called current node, and let's call it head.next node. And this current node is going to be this node, right? And the current node dot next node dot get value will return what? B. And you can use the same technique to access D. You can use the same technique to access E. You can use the same technique to access F. And you can use the same access to get the tail. And when you see the tail, you know that you hit the rest element of the linked list and you stop doing the iteration. Okay, so I will just erase this for the moment. We are going to see the implementation part later, so why don't we just focus on the conceptual part in this slide. Okay, all right. This works okay. And then what you want to do is you want to find the D and C here. You finding C, no hit, no hit, no hit, no hit, no hit. So it still requires n retrievers, right? So it's n retrievers. If it doesn't have C here, it's n retrievers. If it has like the D, it hits, right? So in this case, maximum n retrievers is same as zero arrays. Okay. How about the linked the search pattern, search procedure was the same as the zero arrays? How about the insert and delete? Actually, that's the fun part. The insert procedure, so we don't have C. We want to put C here. The algorithm, this procedure of doing that is this one. Okay. So last time you needed n retrievers to insert a value, because then you, even though you are inserting C, you have to touch A, B, and D, F to copy and paste, right? But this time, what you're going to do is that you start from the head, right? And you navigate to this point. It requires 2 retrievers, right? And when you hit here, and what you are going to do is that and you are going to call this as a node prev, right? And then by using the get next node method, you can get the node next. And what you are going to do is instantiate a new node new. First, you store a node new, and pointing a reference, and then point this node new will hold C here, and pointing the node next as the next node, right? And then second, this node prev is the next node, right? Its next node is pointing at node next, and we are going to call this set next node method, and we are going to set the next node to the node new, right? Okay. And then third, you change the reference node new to the node next. If you did that already in the first operation, then you don't have to do that in this third operation. So it's just 2 or 3 operations at the moment to insert it. And then what happens? Let's see what happens. If you want to find out where the C is, you have access to head and get next node, and you have A and get next node, you have B and get next node, you have C and it hits. And if you are going to find G right in this linked list, in the next node, you have this head node access and get next node, and then you have this node and you check the value is A, you check the value is B. You are using the next node, get next node method to navigate, and you get next node and you have C and you have D, E, F, you don't find G, and then it still requires N retrievers. But anyhow, in the insert procedure, you just require a 2 or 3 instructions here, right? Store this node and update this reference and add this reference, right? Okay. So it's just simple. You don't have to touch A, E, and F to handle this insertion procedure, right? So this overwritten reference is a key. Overwritten reference in the node pref to the node new adds a new path to navigate through to node new. Okay, that's how we insert things, instance, how we insert node by using the linked list. Okay. How about the delete procedure in the singly linked list? Okay. This is another moment of power that you see the linked list. The last time you needed N retrievers to delete a value in the cell array. However, this time you require just 3 operations. And you just retrieve from, if you want to delete D here, you navigate through by using the next node, A, next node, B, and get next node, C, and get next node, D. You see the D, and then you store this node C as node pref, and D as node remove, and the next node is going to be node next. All of this finding out these nodes can be done by using get next node. Okay, get next node method. And then what you're going to do is that by setting this node prefs next node reference to the node next. You can just set it like that. Previously, it was pointing node remove, and the next time this node next is going to be pointed out, right? You first retrieve node next and 2 steps node pref and so forth, and second you change a reference from the node pref's node next to the node next. It was pointing node remove, but now it's pointing node next. It's just a 1 or 2 procedures, and then what happens is that, okay, we have this head access, and then we navigate through to get by using the get next node method. We have A, B, C, and get next node, then it will point E, and E, and F, and tail. So D is completely removed, right? So what happens is that first we retrieve the 2-step next. So we have node pref, node next, and node remove, and then update this reference, right? And this overwritten reference to the next node will be acting like the removing this instance. Okay? Because there is no reference pointing this node remove node. This node is completely out of our scope. Okay, so we talked about this as a with some kind of conceptually, and this is an actual implementation. I want you to stop this video for a moment and try to implement type in. Actually, you have to type in, open your script editor, type in this, and see what happens, right? And this is the script editor part. This is the main console part. What you want to see, what you want to look up, investigate more precisely and meticulously is here, this insertion part and this removal part. These four statements are the things that we discussed with graphics. And these three statements are the things that we discussed in graphically with diagrams in the previous slide sets. So why don't you pause for a second and see what happens. Okay, so you did that, right? And by using this get next, send next, get next, and send next methods, you could re-link these nodes. And by re-linking these nodes, you could expand the horizon of the linked list, right? So we are going to experiment more on this in our classroom lecture. Okay, so this was a very simple singly linked list. And what we are going to cover next time in part 3 is that there are variants of the linked list. And those linked lists are much handy and comes in pretty adaptable to our real world usage. So we are going to discuss that for a moment, right? So please do type in these programs. That's how you run programming. Without typing, you will never learn program. If you want to know how to shoot, you have to shoot it. You have to fire a weapon or something. If you want to shoot balls, right, in soccer, you have to practice your shootings in the soccer field, right? If you want to learn programming, you have to type in. It's simple as that, all right? So I'll stop here and let's see in part 3 of the week 3.